quickly wanted to bring my afternoon MC, Lee Steinke, whom I'll properly introduce later on, but I wanted to bring her on for a really quick and exciting announcement. Lee, are you on here?
Yes, thank you, Leo. I just wanted to share with everyone our excitement about our next Conversations for the Future event. You can tune in on June 8 and 9 for conversations about space logistics, how we move things around in space, and the life cycle of spacebound items on Earth. Think of it as semis in space or roads and railways of space, as well as space traffic management, which will be a growing issue. Space logistics is a key component of what is going on in space today and will also grow in importance as activity levels grow. So we're really excited about the energy that we feel around Conversations for the Future, and everyone here tuned in on the call itself, as well as those on our various live streaming platforms. Thank you so much for being with us. And you can register for our upcoming Conversations for the Future on space logistics at www.f4f.space, and keep an eye out for social media posts about that event that you can share with your networks to grow this effort. Thanks so much, Leo.
Thank you, Lee. We'll be seeing a little bit more about you in a little while. But before we actually bring in our next speaker, I quickly wanted to introduce one of our, someone from our team here at Foundation for the Future, Emily Mishler. Emily Mishler is in the development office for Foundation for the Future, and she specializes in business development, creative strategy, and fundraising. As I mentioned earlier, I did bring on Emily, but I'm going to intro her really quick. Emily launched her first company at the age of 22 and has since raised and distributed over $20 million of private investment for private clients, for-profit entities, and NGOs. She runs a group of impact-driven companies called the Cultivator Group and is on a mission to ignite and empower individuals and organizations to be the change you wish to see in the world. Welcome back, Emily.
Thanks so much, Leo, and thank you so much for that generous introduction. It gets me every time. Leo, I was thinking about it, and it's kind of hard for me to actually imagine what a space semi would look like. So I'm really looking forward to next month's conversation.
Very excited.
Yeah, again, it's a pleasure to meet you all and be here today, Leo. Thank you so much again for that generous introduction. As he mentioned, my name is Emily Mishler, and my background is the intersection of corporate philanthropy and creative solutions for revolutionary ideas. Thank you all for joining us in Conversations for the Future today. As these relationships continue to grow and progress continues to be made, it's becoming more important than ever before to have the infrastructure in place to support the Foundation for the Future's growth, which I think we can all tell is tremendous, and there is so much potential there. We're positioning the Foundation to be able to continue this important work for years, if not generations to come. From these conversations today, it is abundantly clear that our work is disruptive, necessary, and the time for building is now. And that means we need your help. The comprehensive vision, expertise, dedication, and momentum of the speakers today, and the business plan competition itself, and the vision of the Foundation for the Future, the powering force behind Conversations for the Future, is inspiring and worth investing in. This future in space and beyond is being built one relationship, conversation, and connection at a time. In order to continue this momentum in building and contributing to this caliber of event, conversation, and community, we need your help. We need you, our allies, attendees, partners, members, advocates, and friends to spread the word about our important work through social media, invite like-minded and like-hearted peers to our events, and to help us connect with philanthropists and organizations who believe what we believe, that the future is in space and it's ours for the building. The time is now. We're so excited to announce 3 different avenues to become involved if you're interested in financially supporting our work. Lila had already mentioned a lot about our membership, but on the corporate level, from a philanthropic perspective, we have the opportunity to sponsor Conversations for the Future and the Foundation at large on a monthly and annual basis to support this important work. More information is available at the QR code on the screen. On a personal level, if you, your friends, or family are inspired to support us, we welcome your contributions to support building space infrastructure and economy. As Malila had mentioned, the Foundation has recently launched a corporate and individual membership program whose mission is to connect like-minded and passionate individuals who see the near-term potential in space. We're recruiting everyone from students to CEOs to join us in creating a dynamic ecosystem of young enthusiasts, investors, entrepreneurs, and larger industry partners inside or outside of the space industry. We welcome all who want to join and contribute to this urgent conversation, which inevitably impacts us all. More information on membership is available on the Foundation's website f4f.space/membership. So what's the ask? Help us in making space boring, because the time is now and the world can't wait any longer. If you have any questions, please don't hesitate to reach out to myself, Lila, Tim, Leo, Lee, or any affiliate of the Foundation for the Future. Our contact information and a link to donate is available at the QR code on the screen and also available through the website f4f.space. I'll be happy to stick around in the Zoom call and field any questions. If you all on the live stream have any questions, please don't hesitate to put them in the comments and we'll make sure our team gets back to you. Thank you so much. And now I'll turn it back over to our MCs for our regularly scheduled programming.
Thank you so much, Emily. To everybody watching, your help in the ongoing efforts to make space accessible to all is not only appreciated, but also very important. So now, without further ado, let's hear from our next speaker. Our next speaker is James Vedda, and James is a Senior Policy Analyst at the Aerospace Corporation Center for Space Policy and Strategy since 2004. He performs research and analysis of civil, commercial, and national security space issues for a variety of customers. Previously, he spent 6.5 years assigned to the Office of the Secretary of Defense working on space policy and homeland defense issues. He has a Ph.D. in political science from the University of Florida and a master's degree in science and technology policy from George Washington University. His many publications include 2 books. One, Becoming Spacefarers, Rescuing America's Space Program and Choice, Not Fate, Shaping a Sustainable Future in the Space Age. Hi, James, how are you?
Hi, how you doing? Good to be here, coming to you from high atop my space library. I've been asked to give you a rundown of what we put in a new paper that came out last fall as part of a larger project at Aerospace Corporation's Center for Space Policy and Strategy. Now, just to give you an idea of the general thrust of the project, with the new presidential term coming along, we spent much of last year and into early this year preparing a series of papers, about 20 new papers that were on topics that we thought would be decision points for the next presidential term. So we have compiled those, and I have submitted to this conference the links to the compilation of those papers, and also to the paper that I'll be talking about today on solar power satellites. You will be interested to know that the chapter that we put in there on solar power satellites was not just me pushing for that to go in there. It was our upper management asked for it too. And at least one member of our board of trustees said, hey, you've got to do a chapter on this. So the interest is definitely out there. And I wrote this chapter along with my colleague at the Policy Center, Karen Jones, and I'll give you a rundown of what we have in that chapter. And first of all, did that too. I'm going to share my screen here in a second if I can get this to cooperate.
No worries.
Sometimes it's.
Yeah, sometimes it gives the options to share certain screens depending on what windows you have available.
Yeah, I just, let's see, let's try.
Just in case, Michael, do you happen to have the presentation just in case?
Yeah, well, okay, so actually we can skip that because I was just going to show the cover of the compilation. It's not that important. I do not have any slides that I'll be presenting here.
Jim, I have the paper if you'd like me to pull it up.
No, that's okay. I want to have that paper available to everybody because there's free download at our website. But I don't need to have anything, any graphics or anything for this presentation here. I just thought that if I showed you the nice graphics they put on the front of the compilation, it's better than looking at my face, so that's an improvement there. But we can go on and let me tell you about what we did. As I said, we were trying to find out what were space-related things that would come up for decisions in this presidential term that we just recently began. And And one of the things we decided is solar power satellites, because even though we're talking about the systems that would go operational and really reach fruition probably 20, 30 years into the future, the decision time is now, because there is work to be done. There are a lot of considerations in regulation, international law that go along with the technical concerns. So really, decision time is now to make this happen by mid-century. So what we did in the paper is we broke down the user communities into three groups, and the first group is the terrestrial electric power providers. Now, this is what you've been hearing about for half a century, that we would generate power in space, beam it down to Earth, and it would be part of the terrestrial electric grid. And this has always been presented as the most important, most compelling application of solar power satellites. And I believe it's still a very valid thing, but it may be the last of the applications that really comes online, because it's going to be competing with terrestrial renewables, with the continuation at some level of fossil fuels. So there are going to be economic hurdles that it will need to achieve before it can be a valid ongoing process in the terrestrial power grid. So that thing you've been hearing about all of this time, I think it will happen, but it may be the last of the things that come into play. So the second group of users are terrestrial power users that have unusually high demand, or they're located in remote locations, or both. And I'm talking about here isolated towns, say somewhere in Alaska, or even in the Rocky Mountain area, or places elsewhere in the world as well, say in Australia, or it could be military bases. They always have to have their own independent power capabilities. Large mining and manufacturing operations, large electric rail transportation systems. If high-speed trains are developed in more and more areas, then we'll have to see about how to power them in ways that might make them independent from the grid. So there might be these specialized users that could benefit from beamed power even before we're ready to plug it into the grid. And some of these have very high costs, and nowhere is the cost of electricity higher than in forward deployed military operations, because it's measured in human lives and combat effectiveness as well as in dollars. We learned this lesson well during the Iraq and Afghanistan conflicts. So that's the second group. First electric power providers, then large and specialized users, and the third group is in-space infrastructure. In other words, providing power to satellites, space stations, lunar bases. So the facilities that are in space and in need of power may be the first ones to come online as operational systems if we see things like the Artemis program become successful, and attempts at trying to extract resources from the moon. If those things become successful, there's going to be demands for power at levels well beyond what we've produced so far in space. So this may be one of the ways of answering that. Now, of course, all along the way, you've heard skepticism from people who don't really believe this can be ever made to work, at least not in an economically sensible way. Now, there's the usual litany of challenges that you hear about the technical and economic feasibility. And of course, the number one is the launch capability required to put very large amounts of mass into orbit to assemble this type of system. That is the most prominent one that you hear a lot, but there are a lot of others that you need to be concerned about. The cost of space-related components, will it be prohibitive? The amount of extravehicular activity that may be required to assemble the types of on-orbit infrastructure that's needed. The costs of ongoing operations and maintenance, and of course, the mitigation of any environmental effects here on Earth. Well, in the designs that have been looked at by researchers over the years, they've been addressing these challenges. And we've seen that they've had some success in doing that. Now, in the 1970s, when this was being studied, and particularly by the project that was being undertaken by NASA and the Department of Energy, they were looking at concepts that had these very large monolithic transmitter receiver structures that were very high mass, and the study parameters required them to determine how they could use this to replace, excuse me, 100% of the electricity demand in the United States, which is rather absurd because our energy supply is always going to be an energy mix. It's not going to be 100% of any one source. So the parameters they were working with in the 1970s were almost impossible to meet. It was like it was designed to fail. So, but it was very large monolithic structures. By the time we get to the 1990s, we were moving to structures that were at least partially modular, but still mounted on a common backbone. So a bit of an improvement in the design. But more recently, completely modular structures have been contemplated to reduce the costs, increase the flexibility, reduce the size of the launch vehicles that might be needed to deploy components. And so these are answering some of the problems that might be encountered in trying to put together a system like this. Now, I like to think of this as the time that we are in now and the stage that we're at with solar power satellites and what we envision for them is kind of analogous to where we were at with satellite communications in the 1950s. At that point, satellite communications were not ready for prime time. We didn't know how we were going to launch the required mass to orbit, especially to geo orbits. We didn't have that capability at the time. We didn't know how easily it could be plugged into the terrestrial communications system. Would it ever be able to perform economically in that situation? We didn't know the answers to these questions. Well, a decade later, we were figuring them out, and we were making satellite communications, including from GEO, a reality by the mid-1960s. So you had, in that case, and in the case of energy, you have a product that has universal demand. Everybody needs communications, everybody needs energy. So you have universal demand. In both cases, you have a structure terrestrially for the distribution. There's a grid system, and you also have laws and regulations governing that, systems that can be just plugged in, as we saw with satellite communications. Once you build the ground stations, plug them into the grid, and you're online. You know, the same kind of thing could happen with SPS systems. Now, the big difference was that, of course, in the early 60s, a huge government thrust to support this occurred. Funding through NASA and the Defense Department, and an encouragement to develop a system that could be shared with the world, win over hearts and minds in the middle of the Cold War. Very big push to do that, and we made it happen. That push is what we lack right now for getting space-based solar power online. So like I said, I see this as this is like the 1950s for satellite communications. That's the stage we're at, and we need to just get over this hump to move ahead. Well, the technical advances that are happening inside and outside of the space industry are actually helping us out quite a bit, and we're starting to get there. As we've been seeing, the launcher development is progressing on many fronts. Launch opportunities are going to be becoming more available and less costly. Of course, we know that solar cell efficiency has improved dramatically since we started studying this. I mean, when NASA and DOE were doing their studies in the late 1970s, they were counting on solar cell efficiency of, I think it was somewhere around 13 or 14%. And, today we'd consider that pathetic. We're doing much better than that today. Then, of course, there's the mass production of the modular components. That's a difficult challenge, but there's a lot of organizations out there who are tackling that challenge for the purposes of making very large constellations for communications and other purposes. So the fast-paced development of modular spacecraft components is becoming a reality today. At the same time, and connected with that, is that we never thought, as much as 20 to 25 years ago, that it was possible to have very large commercial space projects with multi-billion-dollar investments and thousands of satellites, and that was considered fantasy up until the late 1990s. Today, we're considering it as an almost routine thing, and there are many entities out there trying to do just that. So the funding and the deployment of very large constellations is happening. That kind of experience can feed into SPS development. Another thing that's improving is that there's this concern about how much EVA time would astronauts need to assemble a solar power station. Well, robotics are improving to a stage where they can take a lot of that duty from the spacewalking astronauts, and it will not be as much of a concern as we thought it would be years ago. And then finally, for the longer term, harvesting of lunar materials and potentially using them for much of the mass of SPS components. So this is something that may grow from things like the Artemis project that NASA is undertaking, but it's not a brand new idea. I have in my files a report from the Space Studies Institute in 1985 about how 90+% of a solar power satellite could be built from extraterrestrial materials. So this is something we've been thinking about for a very long time. But of course, we in the US are not the only ones who are thinking about this. There are, as we point out in our paper, there are many other countries, and we give a brief rundown of some of the things that are going on, including China, Japan, South Korea, India, Russia, and various countries in Europe that are also pursuing this. And we go on the assumption that if this is going to become a component of orbital infrastructure someday, and additionally may contribute an additional source of renewable energy for Earth, that the US will want to be in the forefront of this high capacity power beaming capability and all its relevant applications, rather than becoming dependent on others for the technology and the services. So now is the time for decision makers to start defining what is the US role in making all of this happen. So right now there's some small scale tests going on, like one at the that is sort of an ongoing test on orbit by the Naval Research Lab for the power modules. But there's a lot more that needs to be done. I mentioned the high volume manufacturing, the payload processing, on-orbit assembly, the microwave beaming at high power levels across very long distances. It's a proven technology. We know we can beam power, but we want to beam a lot more power over a lot more distance. We have to demonstrate that. And then, of course, the design and operation of the ground receivers that will plug this all into the terrestrial system. So what we really need here, and what we advocate in the paper, is that now is the time to start designing the strategy for a large-scale demonstration, end-to-end, complete system for on-orbit demonstration of small levels of power generated and transmitted, so that we can prove that the system works end-to-end and then figure out how to scale it up. So as I said at the beginning, space-based solar power may be in the future, but decision time is now, so that we can demonstrate that these things work and figure out how to scale them up over the next 10, 20, 30 years and bring it to reality. So I will stop there and take questions as time permits. Thanks.
Thank you, James. Dallas Beanhoff on the chat actually asked, and I don't know if this is directed towards you, but maybe you could give a little bit of an elaborate response to it. Solar power satellites are generally presented as being in geosynchronous equatorial orbit. Some of the early users are in high latitudes. Please describe orbital locations for customers at high latitudes.
Okay, so most of the proposals are for GEO, but not all of them. There have been proposals I have seen for architectures in medium Earth orbit as well, and therefore you can use some different inclinations that could service higher latitudes. Now, as far as the technical aspects of that, I'm a policy guy, so I am not as qualified as some of your other speakers that you will be having later to address that issue. But GEO, while it's the most popular architecture, is not the only one that's out there.
Very much so. Can you talk a little bit more about the compilation of papers that were submitted earlier that you spoke about?
Yeah, so we at the Policy Center at Aerospace Corporation, we started doing something like this at the before the 2016 election. We said we should write something that gives advice to the next administration, and we did a small project, just a couple of us writing it at that point, and it went over very well. So our top management of the company said, do that again this time for this election, only make it bigger. So we had we created between midsummer and I guess about January of this year, about 20 new papers on an assortment of topics that we felt would be important decision points in this presidential term, in this 4-year period that we've just started. And that includes things like the orbital debris and space traffic management issues, the airspace integration as launches become more frequent and you have to coordinate with the use of airspace. We had, I know there's one paper in there that's about NASA's Artemis program. We have several papers that are about national security issues. I believe there's also one in there about the light pollution concerns that we have for how the large satellite constellations affect optical astronomy. So yeah, a wide variety of topics that we felt could come to decision points in this 4-year period. And in addition to the 20 new papers that we came up with, we also pulled 7 or 8 papers that had been done in the 2 or 3 years before that were also relevant to these issues. In fact, that included one of my papers about the approaches to developing cislunar space, and talked about the types of infrastructure elements that would be needed. So this compilation, the individual papers are available for free download one by one, and the compilation is a rather large file. It's got like 350 pages and lots of pictures and things in it. So it's a larger file, but also available for free at our website. And just to give that quickly to people here if they don't manage to find it in what I've submitted to the conference, go to aerospace.org/policy, and you will find all the things that we have to offer in this series of papers I just mentioned, in a series that we've been continuing to add to since about 4 years ago. And also I've compiled a space policy archive there that has well over 300 documents going all the way back to the Eisenhower administration. So if you're doing any historical research on space policy documents, I don't think there's any place else that compiles all of these things in one place as well as what I've done here, because I've been collecting these things for like 15 years. And you can look by presidential administrations, by topic, various ways of searching through there. So if you're doing some background research on current or historical space policy, primarily the United States, there's only a few foreign things in there, but mostly for the US, this is a good place to start, because there's a lot in there that that I'm hoping will be helpful to people, so that they don't have to scour the entire internet to find these things. So please, visit us at aerospace.org/policy. Thank
you. And I wanted to ask really quick, because I'm actually intrigued. How did you actually come up with the topics? Because you mentioned that you came up with these topics. How did you actually filter through all of this, and how did you come up to the decision of actually choosing the specific topics that you did?
Yeah, well, a lot of it was just brainstorming among our own group and people that we work with, because it's our job to follow every day what's hot in space policy, mm-hmm. and also to try and make a judgment of what's a near-term consideration as opposed to something that is years away. So we kind of went through that exercise for our 2016 election cycle document. That was a little different design. It was just that there was me and one other person who wrote that piece after interviewing about 30 people around the Washington community to see what their views were. And we decided to do a little different this time and have many authors based on the starting point of what topics did we talk about 4 years ago that are still hot today, and then come up with what has changed, what new ones do we need to touch on that weren't there before. I mean, an obvious one being like the Space Force. I mean, the Space Force wasn't around when we did our 2016 election cycle, and now the Space Force is one of the key elements of development of national security space. So there's a couple of pieces in there that relate to the Space Force. So yeah, we did our own brainstorming about things that we work on every day, and of course, upper management did come down and say, well, do this one, do that one. We have to take their instruction. You got to listen to the bosses too. So
exactly,
that was part of it as well.
Well, I think we're exactly at time. James, thank you so much for that amazing discussion. If you would be so kind as to drop your LinkedIn information, as well as where you can find everything that you just talked about in the chat, so that we can continue networking for this event. And to everybody listening, thank you for joining us for this Conversations for the Future, powered by Foundation for the Future. Conversations for the Future is a nonpartisan event about near-Earth space infrastructure from now to 2030. Foundation for the Future is dedicated to the creation of a public-private partnership for space infrastructure development. So to support this cause or to sponsor one of our events, please visit our website at www.f4f.space. That's the number 4. And of course, we are grateful for the support of our corporate and individual partners.